In this video, I'll be going over our practice problems that we're focusing on as we're getting ready for quiz 4. So this will include adding and subtracting polynomials, going back to solving and factoring our quadratics, as well as operations involving the imaginary unit. So with our first few questions, this is our focus on polynomials. Notice how, make sure that we focus on adding and subtracting, so look to see what operation we're doing. So for the first one, we're just adding. We just have to make sure to combine our like terms. Then I'm going to go ahead and rewrite these two given to us, the polynomials, because they're not in standard form. So I'm going to rewrite the first one as, so this is 8x to the fourth plus 5x cubed minus 11x squared. Then we're adding to that, so that is a negative 7x cubed plus 4x squared plus 15x. Now when combining our like terms, notice how there is no other x to the fourth term. So I'm going to bring that down, 8x to the fourth. Then next we have our x cubed. Well, I have positive 5x cubed minus 7x cubed. So that's going to give you negative 2, then x cubed. Next up, we have x squared, negative 11x squared, but plus 4x squared. That should give you negative 7, negative 11 plus 4, and then x squared. Then last, we have no other x terms, so bring down plus 15x. Then question number 2 is focusing on function notation. So notice with the function notation, we are doing first is, whoa, hello, sorry about that. First is, let me erase that, I don't know what happened, is g of x. We have g of x first, which is 9x squared minus 10x plus 17. Then notice we are subtracting f of x from that, which here we're subtracting 12x squared minus 1. Now, remember, when we're subtracting, that is like a negative 1, so I need to distribute. I'm going to bring down, so I've got 9x squared minus 10x plus 17. Then distribute, so now negative 12x squared, so minus 12x squared plus 1. Now we can start combining our like term. Notice how we have 9x squared minus 12x squared. Now that's going to give you negative 3, so negative 3x squared. Then next up, we have only that one x term, so bring down negative 10x. Then our last here is 17 plus 1, which is 18. So here's our final answer. Question number 3 is asking for the perimeter. So remember, perimeter is just adding up all of the sides. So we're just combining our like terms here. So like starting with 3x minus 4, and then I'm just going to kind of work my way around when I write this out. So here we've got 3x minus 4 plus x squared minus 2x plus 1 plus x squared minus 2 plus our fourth side for the quadrilateral, which is x plus 3. Now combining your like terms, I see I have x squared plus another x squared, making that 2x squared. Next up, we have our x term. So I have 3x minus 2x plus 1 more x. So here we've got 3 minus 2, but plus 1 more x. So that gives you 1 plus 1, which is 2. So 2x. So right off the bat, from looking at my answer choices, I'm going to mark off B and C, and I'm left now with A or D. Here are constants. So negative 4 plus 1 minus 2 plus 3. So if we need to, we can write this out. Negative 4 plus 1 minus 2 plus 3. So here I've got, you can put that all in the calculator, but I'm just going to work this left to right. So negative 3 minus 2 plus 3. So here when combining all of those together, continuing from left to right, you end up with negative 2. So that's why here the final answer is A. Now, question number, moving on, starting at 4, this is our review on factoring and solving. So notice how here our A is greater than 1. So do we have a GCF? No. So I'm going to go right into bottoms up, where we multiply first to last, A times C. So here I've got x squared minus 2x minus 24. Now we can factor here what numbers multiply to get you negative 24, but add to get you negative 2, negative 6, and positive 4. But is this our final answer? No, because remember with bottoms up, whatever you multiply by, now make sure to divide. So divide by 3. Here I've got x minus 2 from negative 6 divided by 3, and then bottoms up. So 3x plus 4. Then question number 5. Notice how now we are solving. So we always need to make sure that our quadratic is equal to 0. But notice how we have it equal to 5x plus 70. And I see my x squared over here. So I'm going to leave my x squared right where it is. So if I need this quadratic to equal 0, then that means I need to subtract 5x from both sides. But I also need to subtract the 70. So here I'm going to also subtract 70 from both sides as well. That means now we've got equal to 0. Then I'm going to bring down, I've got x squared. Notice how we do have like terms. 2x minus 5x is negative 3x. Then minus that 70 here. Then now we can solve. See how x squared is by itself, right? X is 1. We can go right into that factoring. What two numbers multiply to get us negative 70 and add to get us negative 3. So thinking of factors of 70, but because we need negative, right? So that means I need 1 plus and 1 minus to multiply to get negative 70. So here I need negative 10 and positive 7. Then we are solving because this is equal to 0. So remember, that's the same as x plus 7 is equal to 0 and x minus 10 is equal to 0. That's why here our answers are negative 7 and positive 10. Because if you were to solve, right, I would subtract 7 from both sides. So there's my negative 7. And here I would add 10 to solve for x. And there is your positive 10. Question number 6, we are factoring. Now notice here's a special case. We have no x, so we just have our two terms, and we are adding. So with the two terms and adding, this is when we are going to need I in our factored form. But I can't just go right into our two perfect squares because there is, like, if you think about it, no square root of 8, no square root of 50. But there is a GCF. I can divide out both values by a common factor of 2. That's their GCF. So now I'm going to take out that common factor GCF here, and I've got 4x squared, but now plus 25. Now we can continue our factoring. So this is 2 times. If we were to think about it, the square root of 4 is 2. So 2x plus the square root of 25 is 5. And remember, right, because this is the sum of two perfect squares, we do need I. So 2x plus 5i times 2x minus 5i. Then question number 6, we are solving. Notice how a is greater than 1, it is 5. So do we have a GCF? Yes, we can take out that greatest common factor of 5. So I've got 5 times x squared plus 6x plus 5 is equal to 0. Now we can go through and continue our factoring. So here, what two numbers multiply to get us 5 and add to get us 6? Positive 5 and positive 1. Then notice how we are solving, right? Equal to 0. Well, is 5 ever going to equal 0? No. So that's why here our GCF we got from when we factored out cancels out. And here that's why you end up with the answer of D. So because this is x plus 5 is equal to 0, where you would subtract 5, and there's your negative 5. Then here you have x plus 1 is equal to 0, subtract 1, and there's your negative 1. Question number 7. You are solving, and then notice how there is no x, it's just the two terms. So I'm going to solve this by square root method, where here we would always add or subtract first. So I'm going to add 98 to both sides of my equation. Now I've got 2x squared is equal to 98. Now divide by 2, because x was still being multiplied by 2. X squared is equal to 49. Now we're just taking the square root of 49, and x is equal to plus and minus 7. Question number 8, same thing as number 7. Notice how we have no x, just the two terms, so I'm going to solve this by square root method. Here, always again, add or subtract first. So now we're going to subtract 27 from both sides of the equation. 3x squared is now equal to negative 27. Now we need to divide by 3 because x is being multiplied by 3. And x squared is equal to negative 9. Now x squared, so take the square root. Here I've got x is equal to plus or minus, not just 3, right? Because we have the square root of a negative 9, which if you recall, we need that to be positive. So that's the square root of 9 times the square root of negative 1. And the square root of negative 1 is always I. So this is plus or minus 3i, which is why the answer here is B. Question number 9. We are again solving, and our quadratic is equal to 0, so we're good. And a is 1. But when I look at my answer choices, I notice that I have this value here, plus or minus 3i, or 3i radical 2. So that's one sign that we could use completing the square or quadratic formula. Another way is, if you were to think about it, what factors multiply to get us 25? Well, 5 and 5. Will they ever, though, add to get us 8? No. So here, because we also can't solve this by factoring, I'll go ahead and do quadratic formula. So quadratic formula, remember, is x is equal to negative b plus or minus the square root of our discriminant, b squared, minus 4 times a times c, all divided by 2a. So I'm going to first again focus on just the discriminant here. So we can see if we have an imaginary solution and double check that. So here again, we've got our a, b, and c values. We're good to go because our quadratic is equal to 0. So here I've got b squared, which is 8 squared, minus 4 times a, which is 1, times c, which is 25. When you put all that in the calculator, or you can go through and solve, you do get negative 36 as the discriminant. So that shows, right, that we have two imaginary solutions. Now I'm going to continue and solve for x. So x is equal to negative b, well, b here again is 8, plus or minus the square root of negative 36, our discriminant, all divided by 2 times a, which again is 1. Now notice in our numerator, we still have negative 8. So I'm going to leave that negative 8. Plus or minus, well, what is the square root of negative 36? Not just 6, right, but 6i. Remember, we need our imaginary unit here. All divided by 2. So I notice that I no longer have a radical because we had a perfect square here. I'm going to mark off C and D. Then here, simplify negative 8 divided by 2, negative 4, plus or minus 6 divided by 2, which is 3i. So that's why here the answer was B. Now, I could also solve this by completing the square. So let's say for those who decided to complete the square. So I'm going to go ahead and erase all this here, so that you guys could see that you could also solve this by completing the square, where here I would first subtract 25. So we're going to move that over so I can organize. I've got x squared plus 8x plus my blank here, right, to complete the square, is equal to negative 25 plus, remember, right, whatever we add to one side, we add to the other. Then we would take our b term, and there's two steps. We would take our b, which is 8, and half it, divided by 2, and square it. So this is 4 squared, positive 4 squared, which is 16. What we add to one side, we add to the other side. So now here I've got, when writing this as a perfect square, well, what numbers multiply to get you 16 and add to get you 4? Positive 4. So x plus 4 to the second power is equal to negative 9 from negative 25 plus 16. Now I can go through and solve for x. Here, take the square root of both sides, because notice, right, x plus 4 is all being raised to the second power. So now I've got x plus 4 is equal to, well, the square root of negative 9 is not just 3, right, but 3i, plus or minus 3i. So let me rewrite that here. So I've got x plus 4 is equal to plus or minus 3i. Then what would we now do to solve for x? Subtract 4 from both sides. So notice how here I've got negative 4 from subtracting plus or minus 3i. So notice how you get the same answer even using completing the square. Now into our imaginary unit operations. So here you have to make sure that when you have that I to the higher power, we always take our exponent, so in this case 53, and I'm going to divide by 4. When you divide by 4, you do get 13.25. However, we're just looking for the quarters using quarter method. So here I'm going to bring down my 9. Now instead of I to the 53rd power, we only have 1/4, 25 cents. So that's I to the first power. 9 times I to the first power is just I. 9 times I, 9i. Then same thing here. We're going to take our exponent, right? And we're going to divide by 4 because that is going to be our quarters method. So when you divide by 4, you get 36.75. And again, we only need the quarters. Here now we have 3/4. This is negative 16 times I to the no longer 147 power, right? But now I to the third power. Then the pattern I to the third power is always negative I. Then notice how negative times a negative is a positive. So positive 16i. So that's why here the answer is D. Question number 12. We are adding, but we're also distributing. We're multiplying. So let's distribute first. We are distributing not just 3, but 3i. So 3i times 5 is 15i. Then here 3i times negative 8i, negative 24i squared, because they both have I. Then I'm going to bring down plus 12 plus 9i. Then if you recall, we're not going to leave I squared because I squared is always negative 1. So I've got 15i, but then two negatives together. So now we have positive 24 plus 12 plus 9i. Now I can combine my like terms. Here I've got 24 plus 12, which is 36. Then 15i plus 9i is 24i. Question 13, which expression is equivalent to 7 minus 2i to the second power? So recall this is a special case. That is the same as 7 minus 2i times itself, 7 minus 2i. So now I'm going to go ahead and set up my box method here, area model. So 7 minus 2i times 7 minus 2i. Now, of course, you can still do FOIL where you have the front, outer, inner, last. So I'm going to continue with the area model. So 7 times 7 is 49, negative 14i. So now in the lower, you should have negative 14i. Negative times a negative now is a positive 4, but I squared. Then recall, right, anytime we have I squared. Well, I squared is negative 1. So now that positive 4 is now negative 4 here. When combining like terms, I have 49 minus 4, which is 45. So I'm going to mark off B and D. But then we do have like terms here. That is negative 14 minus, negative 14 minus another 14. That is not 0. That is negative 28. So negative 28i, which is why the answer here is A. Question number 14. When dividing, you cannot have I in the denominator, but I do notice it's not in standard form. So I'm going to rewrite it as 8 over 3 plus 2i. They were both positive, so I can just switch them. Now we need to focus on the denominator and multiply by the conjugate, which is 3 minus 2i. Change the sign of the imaginary. So 3 minus 2i. Now we can solve. Notice how we're just distributing the 8 here to both terms. So this becomes 24 minus 16i. Then now our denominator. So option 1, you can do box method, or if you recall the pattern. I'll do both here. So the pattern, right? You have just 3 times 3, like 3 to the second power, which is 9. And then you have 2i times negative 2i, which is negative 4i squared. Then if you recall, right, I squared is always negative 1. So that's not 9 minus 4, but now 9 plus 4 because of the two negatives. So you do end up with 13 as your denominator. Then I'll go through and show the box method so you guys can also see that as well, or area model. So I've got 3 and positive 2i times 3 and negative 2i. Now I've got 9, 6i, negative 6i, and negative 4i squared. Now notice the I terms. That's 6 minus 6, which is just 0. Notice how we're left with, inside of the box, 9 minus 4i squared, which is right here from our pattern. So this becomes 9 plus 4, because again, I squared here is negative 1. So there's your 13. Then here, remember, you can also write this as 24 over 13 minus 16 over 13i. Then last is question number 15. Here, notice we are multiplying by negative 1/2 our final answer. So I'm going to move that negative 1/2 value to the side here so we don't forget to multiply. Now we're just taking the square root of 300. So do we need I in our final answer? No. So I'm just going to break this apart here. So I can write this as the square root of 100 times the square root of 3. So this is 10 radical 3, because the square root of 100 is 10. So don't forget, though, we are multiplying that by negative 1/2 here. So negative 1/2 times 10, negative 5. So negative 5 radical 3.